Hi guys, welcome back to Network Geeks. I am Sukhbir Chahal. Again, we are in second video of CCNP ENCOR course. So this video is regarding the drawback of static routing and about dynamic routing. So in last video we just go through static routing, how to configure static routing and all these things. So here now we are talking about challenges in static routing, right? So static routing has some challenges that we can face, like static routing is not scalable. So that means if we are going to implement static routing on a big network, so this is not scalable because there will be challenges to configure manually static route and there can be loopholes as well. So that's why we never prefer the static routing and need to add and remove the routes manually. So if we have to add some routes or need to remove the route, so that is also manual process. And there is no dynamic update of network liveliness. If there is any change about any network, if any network is up or down, so there is no update, so we have to do all these things manually. So these are the main challenges with static routing. That's why we prefer dynamic routing, and here we have some points about dynamic routing, why we should prefer it. So dynamic routing, instead of using static routing to get dynamic or live update of network, use the dynamic routing protocols to exchange the route information. So we prefer the dynamic routing protocols over static routing because static routing is not giving you liveliness or dynamic update in network. And if we talk about the benefits of dynamic routing, so we no need to add or remove any route manually, so that is all dynamic. And dynamic routing is scalable comparing the static routing, and it provides the liveliness of the network with dynamic update of the networks. So if there is any change, so all updates come through the protocol. And we have some protocols here for dynamic routing. If you talk about dynamic routing protocols, so dynamic routing have two type of protocol. One is IGP, interior gateway protocol, so which includes RIP, routing information protocol, EIGRP, enhanced interior gateway routing protocol, OSPF, and ISIS. Okay, and the second portion is about EGP. So EGP have only one protocol, which is border gateway protocol, which is the famous one. But here we are starting first of all with EIGRP protocol, and EIGRP is enhanced protocol of IGRP version, and this is known as hybrid dynamic routing protocol because this is the combination of distance vector routing protocols and your link state routing protocols. And EIGRP uses AD value for internal routes 90 and for external routes 170. EIGRP use metric formula to calculate the best path to reach the destination network, and EIGRP uses 224.0010 multicast address to send the multicast updates or to send hello packets to the neighbor, and it's used dual algorithm to calculate the best metric, that is diffusing update algorithm. And EIGRP forms the neighborship and then exchange the update packets about networks. And EIGRP have hello timer with 5 second and hold timer is 15 second. And EIGRP classic mode use 32 bits metric. And first of all, we have one thing that is known as about EIGRP AS number. So AS number is stand for autonomous system number in EIGRP. So basically this gives you idea about a group of routers in EIGRP which have same AS number, which usually managed by a single or a group of administrators. So if I want to manage my EIGRP domain, so normally one domain have one AS number and that is managed by a single administrator if we have less number of routers, or it can be managed by a group of administrator if it is large domain. And the second is EIGRP have some packet types. If we talk about EIGRP have hello packet, so hello packet in EIGRP to form the neighborship between the EIGRP routers. And the second packet is update packet, which usually used to share the network information between EIGRP routers. So if router 1 want to share some X network information with router B, so that is through the update packet. And the third packet is known as query packet. If you have one best path in EIGRP and that path is no more, and router want to look up for the backup path for the same destination, so in that case router sends the query packet. And in the response of query, always router get the reply from the neighbor router. So that reply can be positive, that means there is backup path, or that can be negative as well, that means there is no backup path. And the fifth packet is known as acknowledgement. So that is for reliability purpose, because EIGRP packets are reliable like update, query and reply. So for every packet there is always acknowledgement packet from the EIGRP neighbor router. So the first point is about how EIGRP forms the neighborship between the routers. So there are some criteria that have to meet by the EIGRP routers. So EIGRP uses hello packet to form the neighborship and need to meet some criteria. And there are some parameters. So whenever EIGRP routers shares hello packet with each other, so that hello packet contain EIGRP AS number that should match, and EIGRP key values must match, authentication must match, and EIGRP timers are optional like hello timer and hold timer. So in this example we have two EIGRP routers. Here we have 12.1/24 IP and here is 12.2 IP, and EIGRP AS number is 10. So the first thing, how we can configure EIGRP. So what we have to do usually, we can use router EIGRP and we have to type here AS number, okay, and then we can give network command for the network which we are using on the interface, and that is the subnet mask, or you can use here wildcard mask. So on both routers we have to follow these two steps to form the neighborship. After that, if you want to change the key values, so this is the command to change the key value on both router, but make sure key values always remain same on both routers. So here metric, and then we have weight. So after weight we have first value which is 0 always, so that is for TOS value, so that always remain 0, and the first value is for bandwidth, second is for latency, third for delay, and this is for reliability, and this is for MTU. So by default first and third key value is on and all the other values are off, so that should match on both routers. That how we can change. And after that we have here authentication in EIGRP. So in EIGRP, if you want to configure the authentication, so what you have to do, you can use like MD5 authentication in EIGRP. For MD5 authentication you have to configure here keychain, okay. So under that keychain you have to configure here one keychain name, and under that we can specify the keychain ID and then keychain password, and even we can specify the timers as well to expire the keychain, but that is optional, okay. So these are the commands. You can follow the below commands, like that how you can define the keychain name is here ABC, and keychain ID is 1. So keychain name can be anything on both routers, but key ID and key string must remain same on both routers. After this keychain configuration, we should apply this on the interface toward the neighbor router. So this command helps to identify the method of authentication, which is MD5, and the second command helps to identify the keychain name. So with EIGRP AS10 we are using ABC key, okay. Similar we have to do with R2, define the keychain, key ID and key string, and later on define it on the interface as well, okay. So these are the commands. You can follow the document. So let's start with the configuration. So we are using the same network diagram. We have R1 and R2, both are connected on the Ethernet link, 12.1 with /24, 12.2 with /24, and EIGRP AS is 10. So I'm starting here with R1. I guess IP address is not here even. Okay, so host name is R1, interface E0/1 on R1 is no shutdown, IP address 12.1, and this is the subnet mask, okay. And similar we can configure IP address configuration on R2. So hostname is R2, the CLI is it's slow. Hostname is R2, interface it's 0 by 0, make sure interface is no shutdown, and IP address is 12.2/24. And if you try to check, do show IP interface brief command helps to give you output about the interface and the IP, and then status and protocol is up. So if you try to ping, that must be reachable, and we have reachability. So now we can start with the configuration. So let's start with R1 first of all. So always use router EIGRP. Okay, after that you have AS number. So this is the AS number from 12655535 autonomous system number. So I'm using here AS10. And what we need to do, we need to use network command for this, and we have two options, like we can use the wildcard mask. So wildcard mask is this one, okay, /24 opposite of subnet mask, and subnet mask is this one. So you can use any one of them. And how you can check the EIGRP is configured or not on the router? So show IP protocol. So we can check. We have here here you can check show IP protocol. So this is just application because of the virtual device. And if you check, we have EIGRP with AS number 10, and here you can check EIGRP protocol AS number 10. These are the metric weights. K1 is on, K2 is off, K3 on, K4 and 5 is off, right? And this is the router ID, and this is the distance for internal and external routes, okay? And here we have enabled for 12 network. And similar we can enable, if you check show IP EIGRP neighbor, still there is no neighborship. Why? Because R1 is not getting any hello packet from any router. So let's enable on R2 as well. Router EIGRP AS10 and network 12.0. So I enabled here as well, and we are hoping for the neighborship, and you can see the log message EIGRP IP410 neighbor 12.1 on interface Ethernet 0 by 0 adjacency is up. So show IP EIGRP neighbor. So we have here now neighborship, we can check. So we have neighbor address is this one, on our interface it's 0 by 0. So this is the whole timer remain, because whole timer always start decrementing from 14, 13, 12, 11, 10 and again start from 14. Okay, these are few more timers here. And similar we can check on R1 as well. Show IP EIGRP neighbor. So neighborship is found on both devices and it's visible clearly. So how we can change the parameter, that is the first point. So if you want to configure EIGRP, make sure the parameters are remain same, like AS number is same on both routers, that's why they form the neighborship. But if you check on R1, I want to change the metric values. So these are the key values. So I want to enable like K2, only K2, not the other values. So let's change it. So move to the router EIGRP and metric weight. And if you check here, first of all we have to give here value from 0 to 8. This is defining the type, and which type, this is defining the toss, but it's only supported 0, so keep it 0. And now it's starting with the K1. So K1 I want to make it 0, K2 I want to make it on, K3 is 0, K4 0 and K5 0, right? So if my metric weights are changed on R1, so you can see there is a log message which is giving you the idea the neighbor is down and the K value is mismatched. So we should configure the same K value. So let me copy it from here and paste on R2. Router EIGRP and paste it. So now we are hoping for the adjacency again, and it's here. If you check the K value, show IP protocol, and we can check the K1 is 0, K2 is on, K3 is also off, and these are already off, right? So that's how you can change metric values, but EIGRP recommend to use only K1 and K3. So now the next point is, if you want to use the authentication in EIGRP, the first thing we have to configure here keychain. So keychain, we have to give here a name is ABC, and key ID you can give this ID, and ID remains same. Key string, you can give any string here, like I am giving here Cisco 123. So this is my key. So you can verify the keychain first of all. Show keychain. So we have here keychain ABC, the key ID is this, and this is the string. So we have not defined any time lifetime for accept or send. That is the default one, always, right? And similar, now before applying on R2, we can configure it on each 0x1 interface. So IP authentication EIGRP, mode EIGRP, AS number, and mode is MD5. So we defined here MD5 IP authentication, and now we have to define keychain EIGRP 10, keychain name is ABC. So we have configured. If you check the configuration of the interface, the configuration is there, but how we can check? Show IP EIGRP neighbor, neighborship is not here. Detail command, okay, show IP protocol. I think that is not even visible here. We have applied, but we can check on the interface with the running configuration. So similar, I am going to put the same configuration with show run pipe section keychain. So this is the keychain. We can copy and paste on R2. So put it in the global mode, okay, and now move to the interface. It's 0x0 IP authentication, mode EIGRP 10 MD5, mode is this one, IP authentication, keychain EIGRP 10, and that is ABC. So that's how we can configure on both devices. And now you can see the adjacencies again here, and show IP EIGRP neighbor details. It's not visible in here details as well, but we have configured the authentication in EIGRP, and we can see the neighborship is again of show IP EIGRP neighbor. So to know more updates about these things, please subscribe the channel and share the video as much as possible, and thank you so much.